He talks about the fact that we all have sort of informal definitions of what legacy code is. To me, it's code I did not write that I have a hard time understanding, that probably doesn't have test coverage, or at least not satisfactory test coverage. But I think it also could mean that like it uses outdated practices, an old framework, an old version of a programming language, security vulnerability.
Hey everyone, welcome to Book Overflow. This is the podcast for software engineers by software engineers, dedicated to reading the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here as always by my co-host Nathan Toups. How are you doing, Nathan?
Doing great. Hey everybody.
Well, we are so excited for the episode we have today. Just as a reminder, if you're watching us on YouTube, leave a comment, subscribe. We love, especially getting comments from you guys. We love hearing what you're learning from the books and interacting with you. If you're listening to the podcast and your favorite podcast player, take a moment, leave a 5-star review. We like seeing those 5-star reviews tick up. We appreciate anyone who's leaving them, and we want to get some more. Help us out, folks. And also, as a note, the Brian Kernighan interview is live. We interviewed Brian Kernighan, the author of The Practice of Programming. It was a fantastic interview. Nathan, how'd you feel about it?
Oh, it was so cool. Yeah. Also the co-author of the KNRC book, the creator of Awk. He was at Bell Labs for years. He had so many great stories. It was really a wonderful experience, and I really hope everyone checks it out.
Yeah, would it be fair to say that he is a titan in this field? I think you could say that.
He absolutely. I mean, largely, hugely influential, right? I think that especially, and you'll see this in the conversation, Bell Labs, with Kernighan, Dennis Ritchie, Ken Thompson, Rob Pike, they had a huge impact on the industry, right? UTF-8, C programming language, Unix. I don't know how the industry would exist how it does today without the stuff that came out of Bell Labs. And Kernighan was along for the ride and incredibly humble. Yeah, that's the coolest thing about talking to him, is that you can tell he's chased his curiosity his entire career. And that's delightful. I mean, I aspire to be like that. Can I spend more of my day working on things I'm deeply interested in with people I really love working with, right?
Yeah, the man's a legend, the inventor of Hello World. Currently, he is the director of CS undergrad studies at Princeton. And just like Nathan said, the fact that he is so humble and so fun really, it puts your ego in check. Yeah, makes you want to be more like him. So please check that out. That's live right now if you're listening to this. And we can confidently say that he is not the last author we have interviewed, that more are coming. We take him as we get him. Sometimes the authors respond, sometimes they don't. But when they do respond, it's a lot of fun. So stay tuned, because there are more coming. And we are just so excited about the direction the podcast is taking. And speaking of authors and books, the purpose of this podcast, let's talk about this week's author and book. This week is Working Effectively with Legacy Code by Michael Feathers. This book is in some ways a continuation of last week, because this is part of the Robert C. Martin series. This is very much part of Uncle Bob's philosophy. Let's talk a bit about Michael Feathers, and let's talk a bit about the book. This is the author introduction we get from Amazon.com. Michael Feathers is the founder and director of R7K Research and Conveyance, a company specializing in software and organization design. Prior to forming R7K, Michael was the chief scientist of Optiva and a consultant with Object Mentor International. Over the past 20 years, he has consulted with hundreds of organizations, supporting them with general software design issues, process change, and code revitalization. A frequent presenter at national and international conferences, Michael is also the author of the book Working Effectively with Legacy Code, which is, of course, the book we're reading today. And let's talk a bit about the book. This is the book introduction, again, from our friend Amazon.com. Is your code easy to change? Can you get nearly instantaneous feedback when you change it? Do you understand it? If the answer to any of these questions is no, you have legacy code, and it is draining time and money away from your development efforts. In this book, Michael Feathers offers start-to-finish strategies for working more effectively with large, untested legacy code bases. This book draws on material Michael created for his renowned Object Mentor seminars, techniques Michael has used in mentoring to help hundreds of developers, technical managers, and testers bring their legacy systems under control. And this book was written in 2004, so it is a little past its prime, but we still found some great things to talk about. And I think, Nathan, what are your thoughts on the book?
Yeah, I would put this in the same category as the practice of programming in that take it with a grain of salt, right? It's a book that came from a time period in which it's trying to address a lot of issues that were not solved in the industry. But there's a philosophy in a through line that's in this book that I learned to appreciate the deeper I got into the book. So, we read about the first half of it for this episode, and it's very much a thesis on how do I take clean code and TDD philosophy and retrofit it on top of a legacy code. I think that, again, some of the focus, especially in the beginning of the book, might make you turn away. I think if I was not reading this for the podcast, I probably would have read the beginning and said, you know what, I have other things I want to read. But because I've been pushing through, especially the last like 70, 80 pages or so, I was like, okay, I get it. Like here's the juicy parts that I'm really excited about. I'm actually really excited about the second half of the book that we're going to be reading. I wasn't a huge fan. It's the same thing with like the refactoring book, which is I think if I use it as a reference, it would be really nice to have these technical examples. But most of the time, I kind of felt like I'm going to skim over some of these bigger code chunks, and it's a bit dated, right? Like the programming languages, some of the patterns that are in place, those things maybe didn't age as well. But again, if you read past it, you still get to some real wisdom that's in there and tactics on how to handle stuff. I think the other thing is I wish there was more real world anecdotes, like in the professional book. We had a lot of these like case study kind of things where you're like, oh, this company had this existential problem and I'm going to go fix it. I wish we had more of that here. I wish it was like this team was, breaking production 5 times a week, and after adding in this pattern that I've been advocating, it stopped. And there wasn't those. I feel like that could have kept my attention better, especially earlier on. But that's just some notes now that I have a lot of books to compare it to in my recent memory. And yeah, I think the last piece is that some of the advice I think needs context. And we'll get into this more, but like some of it, I'm nodding my head. I'm like, okay, in this type of organization, this is a great tactic. But in other things, like especially like highly regulated industries and other areas, you can't be as aggressive with some of the refactors that he advocates. And so I think that'll be fun to talk about.
Yeah, I think something to keep in mind as you listen to this podcast is just for the purpose of this podcast, Nathan and I have chosen when we pick up books, we read them cover to cover, right? Sometimes we split them into multiple episodes, like we're doing with this one, try to do about 200 pages a week, but that is how we read them. And some technical books are really just not designed to be read cover to cover. That's not a fault of the book. It's just, I think it's a good strategy, but it sometimes doesn't fit the purpose of this podcast. That's what this book is like a little. You can read it cover to cover. We're reading it cover to cover and finding lots of interesting things to talk about with it. But the chapters are structured like every chapter heading is a question for the most part. Like, my code is all API calls. What do I do? Right. And so if you were really knee deep in legacy code and needed a good reference material, this is a great book because you pick it up and you flip through and you say, oh, this is the question I have. You go, you read that section, you apply it, you do that. A cover to cover book, it's not as great. Some books work really well for that. We really liked Fundamentals of Software Architecture, Philosophy of Software Design. A Clean Coder was a great cover to cover read. This one, not so much. And so I agree with Nathan. I never consider it a knock on the book when I feel this way, because it's kind of the point of this podcast. But we have had some books where I'm reading through it and I'm like, wow, if I weren't doing a podcast, I would not be reading this right now. And that's part of why we do the podcast, to force ourselves to read them. But I want to call this book a real page turner, which is fine. It's reference material. But keep that in mind if you pick it up. It doesn't really resonate with me because I haven't been real knee deep in a lot of legacy projects like this. I recognize that's a result of me being very fortunate in my career. And not to say that I haven't worked on code that's been around a while. I have. It's just that it's generally been well documented, well tested, functions. For me, I'm reading this and I'm like, I feel like I got most of what I needed out of Martin Fowler's Refactoring. That's the book I would recommend to anyone who's starting, who really wants to get an understanding of, okay, how do I refactor my code in a safe way? That's the starting point. And to be fair, we got this book from Martin Fowler's Refactoring. He basically said, if your code is old and giant and you're afraid to touch it and you don't have any tests and you don't know how to make tests for it, I don't have advice for you. Read Michael Feather's Working Effectively with Legacy Code. So that's what we did. So I just haven't been in that situation a lot of my career, but if you have been, this could be the book for you. And I will say, reading this book, and it's a common through line we're seeing through all the books, and this is going to sound obvious when I say it, it's a great argument for really effectively understanding your code. And I know obviously that's what we should do as software engineers, but I think a lot of us, there's a component to it works, I don't know why it works, or this part is scary, I don't want to touch it. And I've just found in a through line through all the books we're reading that a good engineer understands what his or her code is doing, why it works, how to change it, is really the master of their code. And this is a good book kind of to reinforce that philosophy. So I have enjoyed that as I've been reading it. Maybe, Nathan, we could just kind of get started with how he defines legacy code. His definition is legacy code is simply code without tests. And Nathan, what did you think about that?
Well, I found this definition unsatisfactory. I know where he's coming from, and he makes a good argument as to why. But I think it's a correlation, not causation. In that, I think that a lot of legacy code came, especially in 2004, came from a time in which these expectations weren't set. You easily got this big ball of mud, and then reasoning about the system was really difficult. Unfortunately, I've actually seen this, and unlike your experience, where I think you're in organization structures that really pride maintainability, I've been in early stage startups that have maybe gotten a lot of success very quickly, or mergers and acquisitions in which we took on a code base that maybe didn't have the same structure and standards, where we have in modern times had to deal with a lot of this. To me, the definition is, in the way I think about it, and he talks about the fact that we all have sort of informal definitions of what legacy code is. To me, it's code I did not write that I have a hard time understanding, that probably doesn't have test coverage, or at least not satisfactory test coverage. But I think it also could mean that it uses outdated practices, an old framework, an old version of a programming language, security vulnerabilities, right? To me, legacy code has a lot of baggage. I remember in the transition of Python 2 to Python 3, right? There's a whole slew of libraries we couldn't use until we did the painful Python 3 upgrade. Well, the Python 2 code was legacy code. It could have had 100% test coverage. It actually didn't matter. But I think that wasn't the type of problem what we were dealing with in 2004, right? I think that most people probably reading this book back then were nodding their head, and that was a good enough definition, and he was probably right. It probably didn't have test coverage. Luckily, norms have changed. But I've also seen this where code will get test coverage, quote unquote, where it's just horrible tests, or it just kind of checks some boxes and isn't really testing anything. And I'm sure we'll get into that. But yeah, I'd love to hear your thoughts on the definition of legacy code.
Yeah, I think I agree with you. One thing I've enjoyed as we've been reading these books, the kind of books that are in the Uncle Bob camp, like the Clean Code camp of Martin Fowler's Refactoring, this book, Clean Coder, is it really has changed my perspective on unit testing. I always thought of unit testing as, okay, this is kind of the base level sanity check. We do this to validate the code is working. And I always did my unit tests in a way like that you eat your vegetables, right? But I was always much more of a fan of integration testing. I was kind of like, okay, this is what's actually validating that the system works end to end. This has real value. Unit testing we just do as a check to make sure that the integration testing is probably going to work, right? If our unit test pass, then integration test probably pass, right? But I've really been sold on this idea that the point of unit testing is it lets us modify our code. If we have testing showing that a certain functionality works, then we can change up how that functionality is executed. And so long as those tests still pass, then we're golden. So I see his point where he says that testing, or that legacy code is code without tests, because legacy code is code that's hard to modify, and you can't modify code without your tests, right? But I don't know, it's kind of hard for me to judge these projects, because in every project I've worked on before, I've always just viewed the unit tests as that, again, that first base level sanity check. And so I'm with you that maybe a project can have tests and it can still not actually be accomplishing the purpose that it should be. I don't know. I'd love to like go and revisit every project at every company I've worked on in the past and look at the unit tests and view it through that lens of the purpose of this test is to make it so my code is easy to modify. And then kind of do an audit and say, okay, does the fact that this have tests make it easy to modify? If it does, then it's probably not legacy code. But if it has tests and modifying it is still a big old pain in the butt, then despite the fact that it has tests, it's probably counts as legacy code. So I don't know. It's something I want to think about more as I work through my projects.
Well, it's also it's disorienting because we live in a world now where obviously CI/CD patterns and DevOps patterns serve us well. This idea that I can test often, I can test locally easily, I can then have it in my feature branch, and then it passes a bunch of quality checks. We take this for granted that a good team does this, but in 2004, those patterns largely did not exist, right? There's a couple of quotes I did want to bring up before we move on to the next section. One is to fulfill your point here and also kind of show the author's intent. Code without tests is bad code, which I 100% agree with. It doesn't matter how well written it is. It doesn't matter how pretty or object-oriented or well encapsulated it is. With tests, we can change the behavior of our code quickly and verifiably. Without them, we really don't know if our code is getting better or worse. And that's that objective reality piece, right? Like you don't know. Maybe you did a great job, but again, at some point, someone else is going to modify your code, even if you're not doing it. Unless you have test coverage, they don't know your intent. They don't know what's a safe modification and what's not, and they're just guessing. Maybe you have a prolific programmer who's going to step in and do amazing stuff, but even then, can you prove it? That's a really valid point. The other quote is, when we change code, we should have tests in place. To put tests in place, we often have to change the code. Which, again, I love these sort of duality truisms. It reminded me a lot of practice programming. And so, yeah.
Yeah, it's the whole point of this book is basically, how do I get tests in place to change my code? Yeah. And like you said, Nathan, his quote, sometimes you have to change the code to put tests in place. I love where he kind of he defines two ways that you can change your code. So he's going to mention something called cover and modify. That's what we're talking about, this process of cover your code with unit tests and then modify it and run those unit tests to validate that the functionality works. But he talks about another mode, which I thought was funny. It says, changes in a system can be made in two primary ways. I like to call them edit and pray and cover and modify. Unfortunately, edit and pray is pretty much the industry standard. When you use edit and pray, you carefully plan the changes you're going to make. You make sure that you understand the code you're going to modify, and then you start to make the changes. When you're done, you run the system to see if the change was enabled, and then you poke around further to make sure that you didn't break anything. The poking around is essential. When you make your changes, you're hoping and praying that you'll get them right, and you take extra time when you're done to make sure that you did. And I read this and I'm like, guilty. When I work in a system, this is how I do it a lot of times. And something as we've been reading these books that I've just become, I've been believing more strongly in, is I think there are a lot of patterns we hold as software engineers where, because it takes diligence and skill and a modicum of strategy, we think that makes us a good engineer. Like this edit and pray strategy, that takes skill to pull off, right? We're not just taking a sledgehammer to our code and running it and not having any care as to what we're doing. We are trying to understand the code. We're trying to understand the decisions we make. We're testing it on our own afterwards to validate those decisions. Like, I think you can do that and think that's what a good programmer does. And even the fact that I have these skills at all puts me way ahead of the general populace. And so, I'm proud of the work I'm doing. But as we learned from Uncle Bob last week, we are professionals, and that's not how a professional behaves. Right. And so I've liked learning some of these patterns. And again, it's one of the benefits about engaging with a long form idea is it just really drives into your brain. This is how you should operate. You shouldn't operate in an edit and pray manner. You should operate in a cover and modify manner. And yeah, I think it really strikes at some of those attitudes I hold, where I think because I'm being careful, I'm being a good developer. But it's not enough to be careful. You need to be methodical and strategic.
Yeah, it reminds me of there's an old show in the 80s called MacGyver about this guy who would, get out of these unlikely situations with, a toothpick and some duct tape or something, right? And that is kind of what that, edit and pray method is. And sometimes you do have to swoop in and your amazing engineering skills and a little bit of luck can pull something off, but you don't really want that person to be your architect for your house, right? Like the guy who doesn't have a good plan and put these things in place, like maybe he can get out of a sticky situation with those kind of things. But a lot of times our MacGyver solutions end up becoming structural foundations to future decisions that are made. And I think that's where any one decision wasn't terrible. But if all you're doing is MacGyver code, then all of a sudden you're like, what happened? Because I can guarantee you, MacGyver's not writing unit tests when he's defusing a bomb, right? Like that's just not happening. But his output was good, right? Saved the day, bomb didn't explode, got out of a sticky situation. And I think that there's a lot of pressure for us to be the MacGyver when the business is, maybe they didn't plan things properly or these other things. And it gets back to the professional thing, which is part of our job is to say, look, I've seen this happen before, right? I can defuse this bomb, but we need to make it so that bombs don't get planted at the basement of our building anymore. Maybe that's the whole problem we're trying to solve. And so, yeah, it's really fascinating. I liked this whole idea of changing software. I think this goes through Martin Fowler and Uncle Bob's ideas in general, is that, hey, look, software is this living, breathing thing. We're moving it, we're changing it, and you need these tools to like make decisions so that you don't get tangled up and don't start breaking stuff and don't start introducing more and more problems. I would love to get into a couple areas here that I think we can kind of riff off of.
I think we've set the stage for why this book exists. You've got legacy code. It's hard to work with, hard to change. Now the question is, how do you actually change it? We're going to get into those techniques and more after a quick break. This episode of Book Overflow is brought to you by pull requests. Are you tired of Wild West coding? Are you sick of cowboy coders storming their way through the main branch? Then pull requests might be for you. With pull requests, you can allow developers to work on their own feature branches and then have them submit requests to merge their changes into the main branch. You can protect the main branch by only allowing changes after careful review. And if you don't understand the changes, you can always just approve them and write LGTM. Pull requests, because sometimes a little bit of bureaucracy is necessary. Side effects may include merge conflicts, code reviews, and the occasional sarcastic comment from your lead developer. Pull requests are not responsible for prolonged discussions about variable naming conventions. LGTM is a registered trademark of Lazy Developers of America. And we are back. Thank you so much for tuning in. Well, let's talk a bit about how do you change software, why you might want to change your software, and what that looks like with legacy code. And Nathan, he lists kind of 4 main reasons for changing software. I know that's something you had wanted to talk about.
Yeah. So, this book really builds on these sort of building blocks. And then once you see these sort of core arguments of how he wants to approach things, he gives you a bunch of techniques. And I think it's worth going over. And, maybe we can tie this into, experiences that we've had in life or where we wish that we had had this knowledge to do stuff. So the 4 main reasons he says are, you want to add a feature to the code. You need to fix a bug. You need to improve the design, or you need to optimize resource usage, right? Which I think all of these are valid points. And I think this is, to me, is a much stronger definition of legacy code, is that if you can't do these 4 things, that's legacy code. Sure, maybe test coverage is part of it. And then he actually gives you an algorithm for changing the code. And this is the foundation, again, for all these techniques that are going to come up. He said, you need to identify a change point. He'll define change points. You need to find test points, and then you need to break dependencies, which sounds like it's a bad thing, but he makes a really valid argument as to what this actually does here. You need to write tests, and you need to make changes and refactor, right? So that this sort of rinse and repeat strategy is really the foundation of all of the arguments he makes in this book.
Yeah, let's talk a bit about those points he brings up. I want to talk about breaking dependencies. That's something that really resonated with me as I read this book. Well, I guess let's talk a bit about what dependencies are for our listeners who might not know. I mean, a dependency is when you're writing your software. You have a module of your code, right? You can think of it as a class, right? It's any code that your code depends upon, which sounds reductive, and it probably is, right? But for example, you can think, okay, I have it's called the customer invoice account. but then that customer invoice account needs to access the database. And so it depends on the database. But how you access the database and couple that code together can make a huge difference. And a common pattern you'll see in legacy code is, for example, in the customer invoice account, in the constructor, it'll just initialize a connection to the database all on its own. And that has a private like database access object within it. The problem with that dependency is now if I want to test my code, anytime I want to instantiate this customer invoice object for testing, well, I have to instantiate a connection to the database. And that's completely antithetical to how a unit test should work. A unit test should be its own separate mini application, basically, and it shouldn't have any dependencies on anything outside. So here we have a dependency in our customer invoice class that's really tightly coupled with access to the actual database. It makes it hard to code. The question then becomes, how do we break that dependency? And there's a lot of techniques in the book for that. In this particular example, what could you do? Well, one, he would kind of recommend tackling it in two different steps. The first thing you can do is you can parameterize the dependency by putting it into the constructor, right? Rather than just initializing this database access object within the class itself, pass it in to the constructor, right? This is called Nathan. I'm right here. This is dependency inversion, right?
Yes.
Yeah. So we're inverting where we get that dependency, right? So we are providing it to the class rather than being instantiated within the class. And then another thing he recommends that you could do is he calls this technique extract interface. So now that you've provided the dependency as a constructor or as part of the constructor, you have more flexibility in what actual database dependency you provide to the class. And so he recommends what you could do is instead you could extract an interface. You could basically take all of the methods that database dependency executes within the class, create an interface that mirrors all of them, have the database implement that interface, and then you have your customer invoice class rely not on the implementation of the interface, but the interface itself. Now, why is that important? Because now that we're relying on the interface and not the implementation of it, we can create our own implementation for testing. And this is what's called a mock object, because now you can create a test database class. And the implementation of the interface can just return like dummy values and dummy methods. So now that you've kind of broken all of that out, now you can test this class much easier because you don't have to rely on that hard connection to the database. I've seen this pattern a lot in my career. It was great to kind of see it fleshed out and explained here. Nathan, what's your thought on dependency inversion, dependency breaking, extracting interfaces, really any of the tools he provides to kind of make it easier to test?
Yeah, this is great. And I like one of the things that as we built out our show notes, a lot of our discussions are very linear to follow along with the book. But this book actually references itself in many places.
Yeah.
And so I think it makes sense for us to outline and dive in deep to these techniques, which are actually, we are grabbing from all over the first 200 pages or so. First of all, I'm a huge fan of dependency inversion. You also might hear it called inversion of control. There's whole frameworks called dependency injection, which some people, it makes them shudder. I'm actually, the longer I've been doing coding though, you don't have to do Java style dependency injection to actually take advantage of inversion of control. You also look at, like John Osterhout's book, The Philosophy of Software Design. This interface method is one he encourages a lot, actually, right? It's a well-defined interface. Like when we talk about, the IO library or these other things, you're defining a set of behaviors that you want instead of a specific implementation, right? So a good example, I think when we see a lot with SRE type work is you could write a bunch of print statements throughout your code. You should not do that, right? Because you're taking a very specific implementation. And now you have to do things like if you want to test if the print statement worked, you have to like watch standard out or some like obscure thing that's really hard to do control flow on these other things. But instead, you could create a logger interface. And a logger interface has some methods in it maybe that has to do with like writing a log message with some extra context. Maybe you're smart and you use structured logs and you can test that you've actually added some proper annotations and context to those things. But the cool thing is that if some cool new logging paradigm comes out, like open telemetry or a new logging backend, or you want it to work between local dev and some cool distributed logging service that you have. If those things exist, I don't have to change in a single line of my business logic to accommodate a fundamental shift into how logging works. And so that's where the real power here is not only is it easier to reason about, and I love this. We talk about mocks, and I actually think we overuse the term mocks. He actually brings up there's an idea of a fake and a mock. And I'm a big fan. I think a lot of times when we talk about mocks, we're actually talking about fakes. And he actually defines the mocks as, I have a section for this. Mocks versus fakes is a really near and dear topic to me. But fakes basically are the one that you can inject really quickly and make it pass, right? It's not really doing any real behavior of what the external system would do. So it might be that maybe my function needs the database client, but really I'm doing is a query and I expect a result to come back with 5 users in the thing. Well, I can write a fake that literally just returns exactly what I expect. It doesn't instantiate a database connection. It doesn't do all these like other crazy things I want. All I do is I'm like, I know what the result it should be. I'm going to inject that, pass my unit test. Where a mock, you actually, a lot of times you will a good example of mocks is, let's say you're interacting with an S3 bucket or something more complex, and you want to simulate you don't have write access to that S3 bucket, or the object has to be broken up into several pieces, or a laggy network connection. A mock will give you a lot of the tools to do that, right? Rate limiting, forcing an error to be returned, these other things that are a little more sophisticated, right? A mock is like a lot closer to the real behavior of an external system. And again, he gets into this and I love it. This is what I was calling the juicy part of the best unit test coverage that I've ever seen are teams that really care about this inversion of control and thinking about interfaces so that they can modify the behavior of the system over time without having to worry about where's the 45 places this thing was referenced, right? If you're literally hard coding Datadog, and I've seen this so many times, I'm bringing up Datadog because I'm reeling from this. Datadog will gladly give you the Datadog SDK for Python, and they'll say, hey, here's how you do metrics annotations, and here's how you feed logs to us, and here's how you do these things. And the only problem is the business might decide that they want to move to Grafana Labs. The business might decide that they would rather use some new technology like Core Logix or one of these other frameworks that are out. If you had abstracted out a metrics interface and a logging interface and a tracing interface, especially using a tool like Open Telemetry or something like this, it's a much better abstraction because then you just use the Datadog provider. I can swap it out. Or when I'm doing local dev and I don't want to send my data to Datadog, I just use the local output thing and I can just kind of see in the console that, yes, metrics are working or whatever. And again, it's a much better way of approaching this stuff.
It all comes down to, like we learned from Mark Richards and Neil Ford in Fundamentals of Software Architecture, that everything in software is a trade-off, right? I am so anti-wrapper. I can't stand when we take good existing functionality with, let's take, for example, the AWS SDK, right? That has been so thoroughly proven out by Amazon and works so well. And occasionally I'll see in a project that someone creates a wrapper that just does the AWS SDK stuff. I'm like, oh my gosh, cut it out. I just want to use all of the functionality built there. And there's a difference between if this is, for example, say you worked at a company that doesn't let you use the AWS SDK, you have to use their custom built wrapper around that. That's super obnoxious, right? But there can be a lot of value in your project creating a wrapper around that sort of stuff, right? And this helped me understand that more because this is something that confused me a lot at the start of my career, is I would just see, especially like large Java projects, tons of interfaces. And then you see that interface often only has one implementation. I'm like, what the freak? Why is there an interface here? Well, it's just like Nathan was saying, because it gives you the freedom to swap out the underlying functionality. There's obviously great business cases for that, like, for example, logging, Datadog, stuff like that. But it also can be really helpful for your tests, because you can swap out the concrete implementation for a test implementation, right? And that in a lot of ways can be simpler than creating these mocks using like mocking libraries, like Java has Mockito, for example, right? Sometimes that's exactly what you need to do if you're testing more complicated functionality, like Nathan pointed out. But sometimes you do just need to say, you know what, I'm working through the business logic of how customer invoices are processed. And to do that, I just need the database to return a customer in a format to me. I'm not going to bother with a mock. I'll just create a test implementation of our database interface. So, you can take it too far. You could wrap everything in a wrapper and everything is an interface, and that's not great. But it's a really helpful tool in the toolbox. And it was helpful for me to read this and just kind of solidify that understanding. Me like, oh, yes, I knew interfaces were important because obviously you can use them to swap out the underlying implementation, but it goes beyond just business cases, because it's like, yeah, we're probably not going to all of a sudden swap our implementation out from AWS to Google Cloud, right? Or if that does happen, like, we have bigger problems than rewriting our usage of the AWS SDK, right? An interface would be premature there. But an interface might be super helpful for testing, because that is a scenario where you do need to swap out the implementation constantly.
Yeah. I think another interesting idea here is that, it's really easy for the code to scope creep if you're not careful, right? I love the AWS client. I think it's very well written, very well documented, very capable. But you think about, I'm a big fan of, what does your code do, right? What does your code do? And so it might be that you don't actually care about the AWS client. It might be that you want to constrain what the behavior is. And so you say the expectation is writing to blob store. Well, AWS is probably the implementation you're going to use for that. But imagine if you have a blob store interface, then you can say, okay, well, here's the GCS version of that. Here's the AWS version of this. Azure. I mean, there's a bunch of things. Cloudflare. All of a sudden, now you're problem solving with, I have a key value store where the value could be this arbitrarily large object, right? If you write this interface, it's very clear as what the thing is doing, and you just then conform to that. And so I agree, you shouldn't have a wrapper to just have a wrapper. I think that's that sort of indirection thing, and you can go into this sort of indirection rabbit hole where it's 7 layers deep of indirection. And no one likes that, right? We really don't want that. It's not only is it expensive from like a call stack standpoint, it's also just, it's hard to reason about. And I think at the end of the day, you want to be able to reason about the system. And a lot of these techniques are so that you can do this. I think another one I thought was really kind of cool was, okay, so you have this function, you're trying to figure out, where do I even start testing? And he tells you to look for a seam.
Mm-hmm.
It's like, I guess in the same way of like, if you're altering some clothing, right? I have a seam that goes between where the sleeve is and where the covering for my torso is. If I was going to make an alteration, that's the least invasive place, right? Otherwise, I'm cutting the fabric. But here, I can kind of get into the seam, make some alteration, and if I'm skilled, there's no change to the behavior, right? And I think that this is really a cool way of framing. And of course, a lot of times it is that, hey, there's some functionality inside of a function. To him, adding a seam is this idea that you can alter the behavior of one of the subtasks inside of a function by putting in some place that you can change control flow. So a lot of times, a really simple one would be putting an if-then statement if an environment variable set, right?
Mm-hmm.
So I can put an environment variable that's like, skip db write or whatever, and wrap the db write set of my thing, and then see, what does this do? How does this change the behavior of the code? And that was really a good framing of like how you get into, putting in your first unit test or poking at the functionality of an untested piece of code.
Yeah, he defines seams as a place where you can alter behavior in your program without editing in that place. And I liked that framing because I don't know, it recontextualizes a bit because you think, yeah, I don't have to be working exactly in that place to change what it does. The example Nathan provided is great. A database or an environment variable. Another example would be existing interfaces, because you can say, hey, this code already takes in an interface. I will just in my test provide a different interface, and whammo, I've changed the functionality of the code entirely without actually changing any of that code. So when you have a large code base you're working with and you need to start making tests to it and you're not sure exactly where to begin, that's what he recommends. He says, look for the seams, any place where you can change the functionality of the code without changing that. And the book has a lot of great examples. We've just talked about a few of them, like interfaces and environment variables. But that's a good way to kind of figure out how you can get a foot in the door and start making the changes you need to.
The other one that I liked a lot, it was called the sprouting or sprout method or sprout class. This is the idea that you add new functionality by creating new methods or new classes to modify the existing ones. And so again, you could think of this as, hey, maybe so there is a good interface design. Maybe I'll make a sprouted class would be one that injects particular behavior, right? Mocking is a good example of like sprouting, is that, I'm going to swap out the database with a very specific implementation that I want. One of the things that I thought was cool from a method standpoint of like introducing new methods, maybe you're trying to descope, maybe one of the methods is doing too much. And one of the separation patterns he pointed out, which I thought was really interesting, is the command versus query separation. And so this idea was a design principle described by Bertrand Meyer, which is a method should be a command. A method should be a command or a query, but not both. A command is a method that can modify the state of the object, but doesn't return a value. And a query is a method that returns a value, but does not modify the object. Obviously, you have to take that with a grain of salt. Obviously, you have to solve your problems in a way that's appropriate. But I think that's a really nice way of thinking about separations of concerns, in that giving those discrete steps is a really valuable way to make unit testable methods, right? That, hey, even if I have some sort of more complex method that maybe constructs several of these more atomic pieces, the fundamental building blocks should come out of this thing of, hey, I'm not mutating state, I'm returning some values, or hey, I'm mutating internal state and not returning a bunch of query values. It was an interesting way to frame like how you can maybe break one complex method into little simpler ones, things like this.
Yeah. As like a concrete example, you can imagine a scenario where you have a method like get customer, and that returns the customer from the database, but then you also want to keep track of how many times that customer was returned from the database. I think a less sophisticated way would just be to build that into get customer to have it automatically update. The command query separation principle would say, no, you can't update the customer when you get it. You should have a method for getting it and then a method for updating the count. I think it's interesting you say take it with a grain of salt, because that was one that rang really true to me. And I'm like, I think no salt needed. I'm just going to do this all the time. But I want to, as I program, I'm sure I've written some methods where I'm like, that's a violation of that right there. And the question is, if I were to look at those methods, would I say, but there's a good reason for doing that? Or would I say I should really break this out? Yeah, I really like that principle too. I think, Nathan, is this a good time for us to move into testing techniques?
Yeah, so that was the thing, right? Okay, we have all these philosophies and principles. We have all these tactics that and techniques for doing this stuff. But then he also really gets into how do you actually do this in the testing? How do you use and again, how do you take test-driven development philosophies to kind of push these things forward?
So we'll talk about how you implement this into testing and our favorite topic, test-driven development, and more right after a quick break. This episode of Book Overflow is brought to you by CI/CD. Are you tired of deploying code like it's a high-stakes game of Jenga? Sick of late-night deployments that feel like defusing a bomb? Then it's time to embrace CI/CD. With CI/CD, you can automate your build, test, and deployment processes, ensuring your code sails smoothly from development to production. No more manual deployments, no more last-minute fire drills, and definitely no more "it works on my machine." Imagine a world where your tests run while you sleep, your code deploys with confidence, and you have more time to focus on what really matters, like beating your high score in the Google Chrome dinosaur game. Does it sound like a fantasy? It's not. It's all possible with CI/CD. CI/CD, because that broken midnight deploy wasn't really worth the free pizza, was it? And we are back. Okay, like we said, this book comes from the Uncle Bob camp of programming, which is huge into test-driven development. We have talked about this on the podcast a lot. I think we will probably talk about it until we're 90, assuming we're still doing this podcast. It's a hot topic. Nathan, what are your thoughts on, as you read this book and learn more about test-driven development, especially how it functions in a legacy environment? What are your takeaways?
Yeah, I think that if you want to take a TDD approach to the world, this is probably one of the most invaluable assets. I think that I'll kind of continue my argument in my skepticism of some of the more extreme views of TDD. In that, and I'll say this as somebody who I'm a former CrossFitter. I don't hate CrossFit, but there are some folks who think CrossFit's the only way to get fit. And while I think that if the comparison is between sitting on the couch and doing CrossFit, you should absolutely do CrossFit. But if you're not careful and you haven't learned how to do strict pull-ups and you're just taught kipping pull-ups, which is this like type of aggressive pull-up that they do in CrossFit, you can tear your rotator cuff. You can hurt yourself really badly. I feel the same way about TDD. It's that if it's TDD versus nothing, unquestionably TDD is the best is your best approach of the two options. But there are extremes that you can reach that I think we'll touch on. And I think he gives some examples where I actually vehemently disagree with some of the stuff. But that being said, it doesn't matter if I disagree. If you follow these principles, you're going to write better code. And I would be so excited for anybody to be like, if TDD gets you like excited in the morning and that's what makes you motivated to write unit tests, please do it. That's like, do not abandon unit tests because like I'm criticizing some aspect of it.
And maybe get some other hobbies too. If TDD is really what's giving you joy in your life, I'm not saying that's bad, but there's like hiking or, get a dog. That could be fun too.
That's hilarious.
Okay, so TDD. That I will say with TDD that I feel like this is the strongest test case for it. No spoilers, but we've had some conversations with some folks. And I kind of agree that if you do test-driven development from a blank slate perspective, you wind up with a bit being the tactical tornado, like we talk about in a philosophy of software design. And I think there's a chance where you can have no larger cohesion to your code because you're not sitting down and intelligently thinking, okay, how do I design a beautiful system from start to finish, right? You're just moving one piece at a time. And I think that could be hard when you're starting from scratch. Now, when you're not starting from scratch, when you're working with legacy code, like this book is about, I think there's a lot of value to that idea of, okay, I have to add a feature. Before I add the feature, I'm going to write the test because this feature didn't fall out of a coconut tree. This feature, oh my gosh. I'm regrettably a bit of a politics junkie. And if you haven't been following the presidential election, there's been a lot of commotion about whether or not Joe Biden is going to be replaced. Anyhow, because Kamala Harris is vice president, I have just read nothing but people making fun of Kamala Harris quotes all week. And I'm now using them unironically to talk about this. And she talks about falling out of a coconut tree and existing in the context of all what that came before. So embarrassingly, yes, I'm quoting the vice president when talking about legacy code and test-driven development because my brain is a big pile of mush. Anyhow, all of that to say that, yeah, this code exists in the context of what came before it. And so adding new features to it, I don't know, I can see a big argument for test-driven development there. I don't know.
It's funny. I do think you should drive the test, like testing should drive provability of your code operating. And I love full test coverage. I guess there is a very opinionated way of doing testing that I think of as TDD, like TDD with like a trademark symbol at the end. And there's a few of the conclusions of how you should alter your code or how you should build things that I actually disagree. And I think again, this gets this philosophy of software design. You know, this book and Uncle Bob and others make this really strong case that your code itself should be optimized for testability. And I actually think that it's a form follows function. Like I think that the well-designed software is testable, but that you don't alter the software just to be testable. And that's where I think the pitfall is. And we can actually get into this, but I wanted to kind of cover first of all, what is TDD? Have you ever heard of TDD before? Right? I'm going to give you a couple of quotes that are head nods. I think everyone should agree with, and then we can give a quick description. So one is ultimately this is going to make your work faster, and it's important to nearly every development organization. Unit testing. I agree, right? You have unit test coverage, you have confidence, you know that the system behaves the way it should. I think everyone will agree that with proper test coverage, you can move faster. And then it says nearly every team I've worked with that depended on manual testing, like QA, for its changes has ended far behind. The confidence of the team isn't what it could be. And again, I actually have personal experience with this. There's actually one of the companies we've acquired in my current role. They have a very heavy QA testing process, and a lot of it is to make up for the fact that they have really awful automated testing. Right, automated testing for certain parts of the system just aren't where they should be, and so we make up for it. It's like I call it scar tissue. Right, the company got hurt, you heal. And then you have the scar tissue. And then the scar tissue is like the organizational norms that fall around this. And they go, well, if we don't just keep piling on manual testing, then we're going to have more errors in production. And of course, I go, you obviously need to maintain what you have here, but I'd love to make it so that your job's really boring, right? Kind of we get back to the professional thing. Uncle Bob says
on manual QA. Do you think there's a place for it? I'm going to be honest. I'm fairly anti manual QA.
I think it's antiquated. It is required in some regulatory frameworks. Sure. For instance, I did some work with an FDA regulated medical device. You have to have, and it's funny, QA wasn't to test the device specifically. QA was to test the requirements of the FDA. So like their audience was literally, here's all the rules the FDA gave us. I have to go through each one of these and write a report, and it's a required report for the FDA. In that case, we've been dictated that we have to have manual QA. Now, we still tried to automate as much as that's possible. We tried to give automated reports as much as humanly possible so that they could go in and say, I've validated that this complex interaction happened, right? We're doing the same thing too with, there's a tool, really interesting tool that we're working with this organization called Rainforest QA. It's a company that is test automation for manual QA folks. So it gives them a bridge to describe a set of tasks in a more automated way. I think every modern team takes a very aggressive approach to automate it. And I think there's an overwhelming idea that if you can't automate it, you don't actually understand how the system functions, right? And so, yeah, that's like and I do want to I'd love to hear your opinion on the anti-QA stuff.
Yeah, I mean, so my big problem with manual QA is that it becomes a bottleneck, right? If you have a manual QA process you need to do before every release, then you're not really doing CI/CD at that point, right? Yeah. I don't mind the idea of manual QA if it was almost like an asynchronous group of bug hunters. Like we would do that at this cloud provider I worked at, where like we would try every now and again to do like a bug bash, but that was just all the engineers getting together and just trying to find bugs. Like I could see real value to a team that is constantly doing bug bashes and surfacing bugs and then letting us know about them and we can fix them. Like I could see value to that, but I also just like, I don't know. I don't like just being able to like point to the big tech guys and be like, they don't have it, so we don't have it. I think there's a lot of like monkey see, monkey we do in the industry. Leak code interviews are a big one. There's a lot of good reasons why the big tech companies use leak code as their filter. And really the best reason, right? they have a line of people out the door willing to work for them. And leak code gives you a lot of false negatives, right? There are a lot of great engineers who can't pass data structures and algorithms types questions, right? But there are fairly few bad engineers that can pass them. So leak code produces a bunch of false negatives, but very, very few false positives. So for these big tech companies, which just have so many people out the door willing to work for them, leak code is great because it's a very effective filter. And also with leak code, right? What are you measuring with leak code? You're measuring one of two things. One, are you a natural born prodigy who can just kind of come up with data structures and algorithms solutions right off the bat, right?
Right.
If you are, that's great because Google wants to hire you. They want to handle prodigies. Those people are few and far between. What the second category is much more, which is, are you so obsessive? Are you so motivated? Are you so deranged? And I use that as a compliment, right? Because I know a lot of these people that you study leak code in your spare time to get better at this completely arbitrary skill in hopes of landing a job at a big tech company. Guess what? Google wants to hire you too, if you're like that. So I think all that to say, right? There's a lot of reasons why it makes sense for the big tech companies to do leak code style interviews. But then it filters down to a lot of smaller companies where the same thing doesn't apply, to companies that don't have lines of candidates out the door, that can't afford to be having a bunch of false negatives. Anyhow, and so I think that's an example kind of like monkey see, monkey do in the industry. And with that, I kind of look at like the big tech companies, right? Like this big cloud provider I worked at, there wasn't manual QA, right? They just, this product I worked on, it was private networking software. It was deployed across 35 different data centers, across 500 different hosts, right? Not a single bit of manual QA for it. And there's a part of me that wants to point to that and be like, okay, if we were able to do that without manual QA, then what excuse does anyone have to have manual QA, right? And again, the reason I went off on that leak code tangent is because I don't want to get into the monkey see, monkey do. Google does this, so I'll do it. But I do think there is some validity sometimes to kind of saying, I remember working at, this place keeps coming up. I didn't work there that long, but this little startup I worked at, which was not very fun. And our deployment process was a huge nightmare. And I just remember pointing and being like reading like Amazon's DevOps report and seeing that like Amazon, like the average team deployed like 12 times a day or something like that. And I was just like, Amazon can manage this.
Mm-hmm.
We're not more complicated than Amazon.
No.
So why can't we do this? So I don't know.
No, I think it's a perfect example too, that there's a reason, you know, people look at like engineering comp versus other industries and you go like, why is there such a disparity, especially in the United States, where the compensation of somebody straight out of college or only with a few years of experience is making as much as like an attorney in some cases,
yeah.
right? And part of it is that you're a catalyst for automation and productivity, and machines are going to do these processes correctly orders of magnitude better than humans will. And we have proof time and time again that if you can automate these processes, the business understands what it's trying to build. It understands how to operationalize excellence, these other areas, that this is really not a debate at this point. If you're relying on manual testing, you will be slower. You will make more mistakes. You will skirt through. And I think the other part is that, and this gets into the clean coder, the expectation that engineers must produce excellent code doesn't exist in an environment in which it's QA's responsibility to find what your mess up was. We've seen this where we use like a get flow where I'm trying to impact change by moving to trunk-based development. I'm not going to get too much into trunk-based development, but it's how you do a lot of the most amazing stuff, how you deploy to production several times a day and things like that. Instead, we use get flow, which was very prominent a few years ago. But the only problem is that you end up getting these long-lived feature branches. And I'll tell you, especially if you combine that with QA, where things get really bad is someone might write a feature. It works for them. They may even put some test coverage or a little bit of whatever. But 2 months goes by before it actually moves back into whatever release candidate it's going to be there. And then QA has to test it. And let's say it takes another 2 weeks or 3 weeks for the QA environment to go through. We're talking 3 months now since the person wrote the code to when the QA might have found a bug. That code's not in their mind anymore. They're not thinking about it. They've moved on to 10 other features at that point. And and if you don't have an ownership model that's healthy, it doesn't get fixed properly, right? We'll patch it later, or here's we can do these other things, and it's disastrous. It is incredibly disruptive. It's much better. I talked about this before. If a customer finds your bug, you're giving pain to the customer. The customer goes, "Oh, I'm frustrated. I can't use the shopping cart or whatever." It's horrible to the business. I would much rather move the pain closer to when the developer wrote the code, right? And that's what unit tests do, right? Unit testing in general is, if you made a mistake, if you make something that doesn't work, you want to find it as early as possible. And you want the person who accidentally introduced the mistake to fix it as early as possible. It's the best time to fix it is right now, right? And I think that's the part I agree with TDD, right? Is there's this real pressure that it's your responsibility to do this. It's your responsibility to provably write excellent code. And with this, we can build entire systems on top of it. We can build automated release processes where we go to production, dozens or hundreds of times a day. But you can't do that without the person doing the building actually buying into, here's how we hold ourselves to that standard.
And I do like TDD, how it characterizes what we do in the context of the business. I think we have a tendency as software engineers to hide behind like best practices. And we just say, well, we do this, we write unit tests because everyone does it. TDD isn't saying, well, you write unit tests because that's what a good software does. You say, or a good software engineer does. You're writing tests because you're saying this will increase our velocity. This makes us more confident to add features, to fix bugs. This helps us move faster, deliver value for the business faster. So I do like that with TDD. By the way, listeners, as you're listening to this right now, sometimes we go on tangents like this. Let us know in the comments right now. I'm talking to you. If you think I'm not talking to you right now, I am talking to you. Leave a comment. Talk to us on Twitter. Email us at contact@bookoverflow.io. Do you like these tangents? Do you not? Do you wish we were just back talking to the books? Like we said, you don't have to have any sort of degree or certification to start a podcast. So we're just kind of winging this, but we want to hear from you. So let us know if you like these tangents or not. We can do more about them or less of them.
Speaking of book-related tangents, what I disagree with, and I think actually comes in conflict with something I loved in the philosophy of software design, is on hiding things. So there's a whole section here criticizing the fact that hiding things or using advanced language features actually harm the testability of the code. I disagree here. I actually would say I disagree vehemently, because one of the things I loved in John Osterhout's book is he talks about deep modules versus shallow modules, or these wide modules. And if you do, so he basically argues that, hey, if you have all these like private methods, it can be hard to test it externally. And so therefore if you can't test things properly, you should just make them public. The only problem with this is, yes, you've made a form of testing way easier. You've opened up a bunch of like function functionality. You can poke and probe and do all this stuff, but you've turned your class into something that's really wide. And you're going to give unintended functionality to the end user that you made it easier for your testing, but you actually destroyed developer experience. People will start using your class in a way that you didn't intend because you opened it up to make it easier to test. And so, and maybe this is an aspect of the language that I don't quite understand that he's talking about. Like in Go is a good example. If I'm writing my tests in the same library, and Go encourages this, we have all kinds of ways of having private methods, private functions, private variables, private. We don't have classes in Go, but there's structs and the stuff. You can make them private, and you just put your test framework inside the same folder as the code. And so then I have access to all the private stuff. I can test all the functionality of those private things. I think actually, though, it's still valuable to test the external piece, the part that is exported. But I think that you can design testable code and honor hiding things. That the encapsulation is a feature and not a bug. And so this idea that helpful language features you're again, it's the trade-offs piece. I might need it for security reasons. That language might have something that I really don't want, something passed around externally. I really want to keep this state kind of locked in to a private section of something. And it's okay. I can be creative. I can do both. You can hide things and write testable code is, I guess, my hot take.
Yeah. I mean, I've been in a situation where it's like, oh my gosh, I have to test this method. It's a pain trying to get to it. It's private. If I just made it public, I could test it. I don't know. To me, I very much viewed this strategy as like the silver medal of like, listen, if you're in a big, large legacy code base and you just have to get some tests written because you have to kind of get into this feature, it's okay to make it public for just a little bit. I liked his compromise strategy where he basically said, okay, instead, what you can do is take those methods on that object that really should be private, but you want them public to make them testable, extract them to a different sort of helper class, make those methods public on the helper class or protected, and then have that helper class be private in that initial class you are in. So that way, if someone's still working with that existing module, they still don't get access to all of those methods. They would have to instantiate a helper class, that new helper class you created.
Yeah, that's clever.
Yeah,
that's clever.
You are risking that someone will instantiate it and start working with it. I mean, part of what he says is like, well, and that's part of working in a team. You just have team norms and team rules. So I think if you are looking at private methods like that and thinking, I'd really just like this to be public, that's the approach I would make. See if you can group them into some sort of common helper class, take that out, make those things public, methods public there, and make it private on that class. That'll sort of, it's like cheating a little, but it still preserves that private functionality on the class that you're really working with. And again, I don't think it's likely that some developer on your team is going to be like, oh, hey, look at the new class, right? I'm going to instantiate it. This is different if you are maybe providing this as an SDK. I don't know.
Yeah, no, and that makes sense, actually. I think that there's something interesting about that pattern. And you could also make it very clear in the comments, in the way that you named it. It maybe emits a warning if you try to run it outside of some test flag being on or something, right?
Yeah.
One of the things I did like, again, and I think that's, again, it's a valid trade-off. And again, everything's trade-offs, right? My only fear is there was no caveat with this. And this, to me, again, it got into this shallow module pattern that people will start using. Again, you're going to write it. Nobody's going to touch it. They go, oh, cool. There's this method in here that I can like have access to, and I can interact with this thing. And then you realize it kind of broke the original design. That was my only fear, is that one of those decisions doesn't break the system. 45 of those decisions over 6 months breaks the system, right? It becomes something that you're like, oh, this isn't elegant at all, like weird. One thing I did like, and I've never seen this framed this way, what he called characterization tests.
I want to talk about that. Can I mention one thing about what you had just said about people relying on your modules? I actually found this, and there was a post in the Experience Dev subreddit, which cracked me up. You ever heard of Hiram's Law?
No, I don't know that one.
It's hilarious. Put succinctly, the observation is this: with a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody.
Okay. I knew of that principle. I didn't remember the name. And that's absolutely true. That's the real fear I have of breaking an elegant design to quote unquote make it testable.
Yeah. Like the Experience Dev subreddit, there are hilarious stories about people saying that, like, even though they were returning like proper HTTP codes like 200 or 404 or 401, that this team was ignoring those and were instead relying on the error messages and had created like this custom parsing logic to like basically reverse engineer a 404 if the error message had like not found in it. And so then when they just like swapped up their error messages to make them more descriptive, it broke everyone. It broke this entire team's testing flow.
I'm not surprised.
Or someone was talking about how they worked on like software for like manufacturing, and like it was like a touch screen, and so it had like you could swipe through and select like if you need a new piece sent to you or something like that. It was something like that. That part's not important. Anyhow, he changed the font size to make it like more readable, but it turned out the workers weren't reading they were so familiar with this software that they weren't reading the actual buttons they were pressing. They just knew which ones to press purely by how big how long the string was. And so he changes the font size and like shuts down the factory for a day because everyone's got to learn it. And so I think this idea, like you talk about, as we are making methods public, and you think, well, I'm making it public just for testing purposes. No one's actually going to rely on this. Remember Hiram's law.
Yep. Somebody will. I mean,
Somebody
that's
will.
the thing. Yeah.
Well, and so let's talk about characterization tests, because I thought that was a fascinating way to think about tests.
Yeah, so this one's cool. So, we talked about, okay, I need to get into the code, find this insertion point, find a seam, maybe, do these other sort of mocks and fakes and all these other things. But he also talks, there's this whole type of testing called characterization tests, which test the actual behavior of a piece of code. So it's this idea that you write a test for the existing functionality of it, and you don't go and fix. You literally just use the test as a way of describing the behavior of the existing system. And it said, if we find something unexpected, then we write them. It pays to get some clarification. It could be a bug. That doesn't mean that we don't include the test in our test suite. Instead, we should mark it as suspicious and find out what the effect would be of fixing it. And I loved this idea of, especially if you have like a particularly unruly, maybe you look at some class, it's got all the dependencies that you dread and fear. It's got all the stuff that you can't even figure out how to get started with a seam, or that you feel like anything that you do might have a side effect. Going in and just writing a bunch of characterization tests and getting this very reliable description of the behavior of the system would help you so much in just understanding what you might be modifying. Because again, this gets into that thing of, oh, I'm going to fix this bug. And you're like, people actually were relying on this, or this failure state was actually handled in some crazy way externally. And if you actually fix it, it might actually break a part of the system because, maybe some part of the system for timing reasons had to retry 3 times to get the right answer. And then if you fix it, it moves really fast and now you have a race condition, right? Like you can come with all kinds of crazy reasons that fixing something or making it behave properly actually could introduce more bugs.
Well, he talks about this in the book a couple times. He's like, let the compiler figure it out. That's its job. This gets back into like that anti-pattern I keep talking about, which is sometimes as engineers, we think if something's hard to do, it must be good to do. It's hard to understand and read lots of code. So we think that's the right thing to do. It's not always the right thing to do. That's what a characterization test can do. Instead of really analyzing, okay, what is this object? How does it work? Just write a test, try to instantiate it, right? And he talks about like just pass like dummy parameters in or all nulls. Let it throw an error. Or like you had like a page that was like a Java class that was like generating like web pages, right? And like that had a method like first line. And he's like he just wrote an assertion like assert first line is equal to A. And it's like, no, it didn't work because first line is actually equal to like, and it had like some HTML tags. Like, okay, but that's what first line does, right? Or you need to pass in like an ID to this. Well, just pass in A or dummy or whatever, some string. See what happens, because you'd be surprised how often the system will throw back and say, ID does not conform to, the specified pattern. And you're like, okay, there's a specified pattern. Now I know how to work with this. I really like this idea of characterization tests just as another way to help you get into the code, start working with it, right? That's something I struggle with in my career, is sometimes just being so scared that I'll break something that
right.
Like I've had to pound it in my head. Like I have it written on a Post-it note taped to my computer. Breaking something is better than doing nothing, because I'll get so concerned about breaking something that I won't start on the task at hand. Yeah. And this can be a great way to get moving on a task without even having the fear of breaking something, because you're just writing a test. You can't break it.
Yeah, I think it's particularly useful if you're new to a team. And and I've done this, right? We hire somebody new. We go, hey, your backlog isn't full. I have this really good research spike, or I want you to look into this juicy thing that we haven't had a chance to look at. Here's the tickets in our Jira. Take a look at this. I think moving forward, writing some characterization tests, if let's say it wasn't properly test covered, or you writing characterization tests for you to say, do I understand how the system works? Or you go in and go, hey, the ticket says that this is how it behaves, but like, look at these tests I wrote. This is not how it behaves, right? It gives you a concrete piece of things to say, I think this is how the world is. Now, staff engineer might come back and go, it's because you actually didn't instantiate the database the way we expected. And it's actually expected behavior if you did this thing correctly, right? Well, okay, that's probably some documented feature that, tribe knowledge understands, but you didn't. And so you still learned something, even if you did it wrong, right? Characterization tests seem like a really powerful way to say, how do I reason about a system I don't understand or isn't understood?
Absolutely. That was one of my favorite parts of the book too. Well, we are going to take a quick break and we're going to be back with kind of our closing thoughts on this first half of the book, because this is just the first half, and more right after the break. This episode of Book Overflow is brought to you by Linting. Are you tired of your code looking like it just rolled out of bed? Do your variables have names like temp and thingy? Well, worry no more. Linting is here to save the day. With Linting, you can configure your build processes to automatically check your code for stylistic errors. Want to restrict the use of system.out.println for logging? Want to forbid ancient C++ developers from ending JavaScript lines with semicolons? Linting might be for you. And the best part? Since no stylistic choice is objectively correct, you can feud with team members for decades about linting conventions, all while feeling smugly superior in your convictions. To support the podcast, open the configuration file for your local linter and add a rule that every comment must begin with Book Overflow rocks. Linting, because code should be predictable, unlike your Friday afternoon deploys. So like we say at the top of every episode, the reason we read these books is in an effort to improve our craft. So we always like to end the episodes with, what are we going to do differently as a result of having read this book? Or in this case, the first half of this book. So Nathan, what do you think you're going to do differently in your career?
I already know immediately the framing for characterization tests. I have this kind of juicy problem that I'm working on where we're migrating from one edge load balancer to another. There's a bunch of rules related to it and a bunch of other things that we're working on. And I'm going to write some characterization tests to understand the existing behavior of the system, not just what people are declared in documents, so that when we write our new implementation, we have a foundation for it. So that's I'm going to start using this and advocating for it as well.
That's me too. Characterization tests were my big takeaway. Being more careful about dependency inversion and making sure that we are practicing inversion of control, and that maybe not automatically wrapping a wrapper around everything and creating an interface, but making sure that that potential is there for testing. That's something I want to be better about. And I just, again, I said this earlier, but this is a really great book for advocating, like understanding deeply the code you write. I want to be better about that, about understanding deeply the code I work with. Characterization tests are a big part of that. And I think I mentioned this in another podcast, but there's another thing that this book has really prompted me to do is I got to get over the mental barrier between the code and the tests. I don't find myself in the test nearly as often as I should. I feel like I'm in the code. I'm coding the whole sprint. And then I go to the test section really quickly at the end. I want to quit doing that. I want to have no barrier between them. I want to be bouncing back and forth between tests and code 30 times a day. So that's something I want to be better about too. And also because we read these books, and we don't want to be the only ones who read these books. We want to recommend these books to anyone who could benefit from them. We don't like to say in this podcast whether or not we would recommend this book, because it's very rare we find a book that just has no value whatsoever. In fact, as far as we've been doing this, we've never found one. But we do think that not every book is for everyone, which is, I think, an assertion the authors would agree with. So we like to say, instead of whether or not we'd recommend this book, we say who we would recommend the book to. So Nathan, who would you recommend this book to?
Yeah, I agree. I wouldn't recommend this for most folks if they just want to learn about testing or learn about these other things. I think Martin Fowler framed it quite well. He said, hey, read refactoring first. That is it's general knowledge that is useful. If you get into the section that he starts talking about legacy code, and he recommended this book, that's exactly are you into the TDD world? Do you really, does Uncle Bob and Martin Fowler's methodology really resonate with you? And are you dealing with an old legacy code base? This is a perfect book for that. This will give you the tools and the tactics.
Yeah, I think if you're someone who's in a big legacy code base
approach
and
this
feels
in a way
every day
you can be a success,
like the code is more in charge of you than you are in charge of the code, this is the book for you. Because in the same way, I really liked when we read Clean Coder last week, because I didn't agree with everything in Clean Coder, but I described it as aspirational because it kind of gives you a vision of what could be, of what a really successful professional might look like. And there might be parts of it where you come away and think, oh, I didn't even know that this is who I could be. I feel the same way about this book, Working Effectively with Legacy Code. I think a lot of people who are stuck in legacy code think, I go to work every day to battle a dragon, and my job is to get really good at battling the dragon. That's not your job. Your job is to get really good at taming the dragon and making the dragon your friend and making the dragon work for you. And I think there are a lot of people who are in that battle the dragon mentality, and reading this book could convince you that the dragon can be tamed and the dragon can accomplish your purposes. So if you're knee deep in a legacy code base and feeling like you have no control over it, pick up this book, because it's going to give you that aspirational vision of what could be and just convince you that a better world is possible. So I would really recommend this book to anyone in that position. All right. Well, thank you for joining us. We'll be back more next week with Working Effectively with Legacy Code. We're going to finish out the second half of the book. Like we mentioned, we have an interview with Brian Kernighan live. And if you haven't checked out the Mark Richards interview about fundamental architecture, check out that one too, because that was great too. You can find us on Twitter. We are Book Overflow Pod. You can find us on YouTube as Book. Contact us at contact@bookoverflow.io. And you can also find me on Twitter at Carter Morgan. And you can find Nathan's monthly podcast, Functionally Imperative, on YouTube at Funk Imp. I always like to think of it as the Funky Imp podcast, but that's just... Thank you so much for tuning in. We really do appreciate you coming along for the ride. We're so excited about this podcast. Big things are coming, folks. We feel really, really strongly about the format, about the potential, and we are excited for what's ahead. So if you're here, if you're listening right now in the year of our Lord, July 2024, then you are just at the beginning of exciting things to come. So thanks for sticking around. Thanks for listening to the whole episode. And we will be back with next week with more. Thanks, everyone.
Thanks.